Hello everyone. In this video we are going to talk about independent and dependent events. Okay. We call the two events are independent if outcome of the one event does not have any influence on the outcome of the second event. So the good example would be something like flipping a coin and then you're throwing a die, because the outcome of the flipping a coin does not influence on the throwing a die. So that will be the what we call independent events. Now, dependent events, on the other hand, is that if the outcome of one event has influence on the outcome of the other event, then we call that dependent event. Okay, so the one thing that we have to be careful here is that when you set up the questions, if you want to determine whether the two events are independent or dependent, they must be connected with the and. Okay, and as you can see, if you see that my setup here, you can see that there's and over here. Okay, so like P, oops, not that. Okay. So as you can see, and. Okay. So once you have those two events are connected with and, now you need to determine whether these two events are independent or dependent. Okay. Another good example of independent event is having a children. Okay. So if you want to have 3 children, let's say. Okay. That means that, if you have, first time you have a boy and, you have a 50-50 chance, right? Then the second one, you want to have a girl, but you still have 50-50 chance, okay, or probability. So having children is 50-50, I mean the independent events, okay? So if you think that way, then we have something called sample space. And the sample space is called the possible outcome. I need to erase this. Okay. Kind of sloppy over here. Okay, so I'm going to rewrite this. It's called the possible outcome. Okay, so we can have 3 boys, that's one way, or you can have 3 girls, or you can have 2 boys and 1 girl, but there are 3 ways. You can have 2 boys and 1 girl, right? 3 this way. Or you can have the same thing for 2 girls and 1 boy. Okay. So if the given problem is like simple enough that you can generate a sample space, then you can always use the sample space to find out the probability. So in this case, if you use the sample space that we just created, so if we want to find the probability of 2 boys and the 1 girl. Okay, and there are 3 different ways that we can count, right? So that would be 3 out of 8. But most problems are not this easy, right? Because this is pretty straightforward. But the independent and dependent events are always going to be key to the questions that you're going to have to answer, right? So for example, let's say you want to find out if you select 3 persons at once, okay, you want to find out what is the probability of that all 3 have the same birthday. Okay, all 3, okay, have and the same birthday. So you can rewrite this as the same birthday and same birthday and the same birthday. Okay, so that's going to be the probability. Now, because of the we are selecting 3 persons at a time, so each person had, they have no, they have no idea what birthday is from the other person. So they're all independent. So in this case, we will have, okay, each person has the 1 out of 365 probability of having a birthday. So that would be 1 out of 365 times 1 out of 365 times 1 out of 365. So that will be a 1 over 365 to the cube. That's going to be very small probability though, right? Because the, let me just calculate what the probability is, okay? So 365, let me see, cube, and so I have something like, let me see, I'm going to write this thing in there. I'm going to write up here. You got 0 points, I think I get 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 2, 0, 5, 6. So this problem, like having a 3 person having same birthday, okay, has very small probability. But as a matter of fact, that this probability is the worst than winning a jackpot in the lotto games. Okay, so that's the perfect example of independent events there. Now the example of the dependent events. Okay. Okay, let's say you are selecting. I'm just going to do this. So let's say you're selecting 3 senators, and you want to select the women senators. Okay. So the problem is that what is the probability that you're selecting women senators? Now let's assume that there are 13 women senators in the United States Senate, and you're going to randomly choose a senator, and find the probability they are all women senators. Okay, so the problem that we are going to do is going to be, first you're going to have to be a woman senator. Okay, and woman senator, and the woman senator. Now, the problem is going to be like this. Let's say this problem is without replacement. Okay, so this is going to be without replacement. So without replacement usually means that once you look at it and you don't put them back. Okay, so that means that next time you pick, now everything's going to be reduced by 1. So that makes it dependent. Okay, and then we will talk about that conditional probability in another video, but that's what that is. So in this case, I told you that there are 13 women senators. So the first time you're going to get is going to be 13 out of 100. That's the probability that you will pick the woman senator. Now, because I said this is going to be without replacement, so 13 out of 100, we just pick the woman senator. But since we already picked, we are not going to put it back, so now everything's going to be reduced by 1. that will be a 12 over 99. And the last one will be the same thing, so we're going to reduce by 1. That will be 11 over 98. Okay, so that will be the probability that you will pick all 3 women senators, right? So let's take a look, see what we got here. I'm just going to multiply these. 13 times 12 times 11 divided by 100 divided by 99 divided by 98. So that's about 0. I'm going to write this thing here. We got 0.001768. So are we talking about maybe 1, 2, but 0.17% chance or probability that if you randomly pick senators, okay, and they're all women senators, it's less than 1% chance there. So if you see the the word that this problem is without replacement, you can assume that this is a dependent event. But if you see something like with replacement, then you can assume that this is the independent events. Okay? So with replacement usually means independent event. Okay? Now there's a good video regarding the independent and dependent events. So one video that I want to suggest is the, I think we talked about this in class, is the O-ring on the Space Shuttle Challenger. So if you missed it or you don't remember, then maybe you want to go, watch that video one more time. Okay, so I'm going to write it over here. So it's going to be a learner.org. I think the video number is like 20. It will say like a random variable. Let me see if I can find the which video it is. Oops. Let's see. Where are we? Excuse me. Okay. It should be something called the random variable. I'm not sure which video number it is, but if you were in my class, you probably have watched. So that was the case that NASA engineer assumed that O-ring was independent, but it wasn't. So that's why we lost the Space Shuttle Challenge. Okay, so assuming the independent events are a very strong one. Okay, so you better make sure that they are independent, otherwise you don't have one. Okay, so I gave you one example each to understand the independent and dependent events. Okay, and there are a lot of independent and dependent events out there that we don't really think about. Okay, and sometimes that wrong assumptions lead to the tragedy or the that unfortunate accidents and things like that. So we need to have a very good understanding of understanding of independent and dependent events here. Okay. All right. Let's see. Okay. Okay, so I'm going to stop here, and then if you have any questions about independent and dependent events, then you can ask me in the class. But I just want to make sure that the independent events and dependent events, you're going to have to read the questions, and you're going to have to determine whether these two events are independent or dependent. And usually the question is phrased A event and the B event. So make sure that you look for the and between these two events. Alright? Thanks. I'll see you in next video. Bye.